Okay, previously we had determined the zero force members, and then we were left with this. This is our F, this is G, we have B here, we have C here, and we have D here. So this is what we were left with. Now, if even if you try to do this by hand, this can be really long as well. Well, it's shorter than if we had to do the whole thing by hand. It's shorter than that, but it's still a little bit painstaking to determine the displacements, then determining the support reactions, then determining the member forces using the direct stiffness method. This can be quite time consuming. So what we can do very simply is that we can, in this case, we can determine the displacements rather simply, even without using a software or a computer program. We can do that by hand and a calculator. Okay, very easily, and I'll show you why we can do that. We can do that because you can see that all of the points, the G point has a support. That means there will be no displacements there. It is a hinge support. B also has no displacement. C also has no displacements. D also has no displacements. So there are only two displacements at location F. So finding out two displacements is not that hard. Right? If you want to do full-scale matrix equations, you can do that. But if you are looking for only two displacements, we can just go with those two displacements. This is what I'm going to show you in this lecture. Okay, so at first, let me just mark up the displacements. Let's say at F, we have U1 and U2. Okay, and then at G, we have U3, U4, then we have U5, and we have U6, then we have U7, and we have U8, we have U9, and we have U10. So if we were to develop the stiffness matrix, let's say KFG or F and G, what we would do, if we look at these matrix equations right over here, this is going to be U1, this is going to be U1's row column, this is going to be U2's column, this is going to be U3's column, this is going to be U4's column, right? Similarly here, 1, 2, 3, 4. Now we can either develop all of these, or what we can do is we already see that U3 and U4 are null because there is a hinge there. Their value are 0. So what we can do is we can cut off 3 and 4. If we cut off 3 and 4, we're just left with this portion. So we can just work with the U1 and U2's value. So what we can do right over here is we can put just U1 and U2's value. So if we consider this, and if we take the bearing angle, this is 180 degrees. So at 180 degrees, C is -1 and S is 0. Okay. So right over here, we are going to have 1 C square. So that's 1. Then we have CS, that's going to be 0. Right after that, here we have CS. CS is also going to be 0. And then S squared. S squared is also going to be 0. So this is for U1 and U2. Similarly, U1 and U2. See that? Okay, so we have got that for U1 and U2 for KFG. Similarly, let's this time we're going to do it for KFB. So there we go, FB. We already know that 5 and 6 are going to be null. So if it were, let me just erase it and write it again. Okay. So for this time, we had U1, U2. So this is U1, this is U2. Then we had 5 and 6. So this is U5, U6. Similarly, 1, 2, 5, 6. Okay, we are placing 1 and 2 at the front because we are considering the member to be FB, not BF. So that is the trick we're doing. We're considering the member to be FB so that it matches the previous matrices U1 and U2 as well. Okay, so here 5 and 6 are going to be null because there is a support there, right? So we cut that off. We're again left with this. So that's what we're going to do. So before we do that, we need to determine the C and S. So from here to here was 180 degrees, and from here to here is 45 degrees more. So 180 degrees plus 45 degrees is 225 degrees. Let me check. Yep, 225 degrees. So at 225 degrees, the value of C, meaning cos 225 degrees, is minus 7.707. Similarly, the value of S is also minus 0.707. Okay, so if you do a C square of that, there's going to be 0.5. If we do a CS of that, there's going to be a 0.5. If we do a CS of that, there's going to be 0.5. And ultimately, if we do a S squared of that, there's also going to be 0.5. So we have also solved for KFB. Now we can solve for KFC. So let's do it. KFC, Kentucky Fried Chicken. Right. Okay. So there we go. KFC. We have the matrix right over here. We just need the value of C and S. Okay, all of these angles are 45-degree angles between the members, because you can see that all the lengths are similar, so these angles are all 45-degree angles. Okay, let's continue on. Alright, so at KFC, at Kentucky Fried Chicken, let's see what we get. So that again, it's 1, 2, and then 7, 8. So 7 and 8 are going to be null. We're just going to end up with 1, 2, C square, CS, CS, and S square. That's what we're going to do. Let's say 225 plus 45. So 225 plus 45, the angle is going to be 270 degrees. So we have a 270 degrees angle here with that. So at 270 degrees cos theta, let me check the cos theta value. So cos 270 degrees is 0, so we have C0, and then we have I believe it's negative 1. Let me just check. 270 sine 270 is negative 1. Yeah. Okay, so 0 squared is 0, 0 into minus 1 is 0, 0 into minus 1 is 0, and minus 1 squared is just plus 1. There we go. So you can see these are all for U1 and U2 values. This is 1, this is 2, this is U1, this is U2. Similarly, this is U1, this is U2, this is U1, this is U2. Okay. Okay, let me just erase this, or this may create confusion later on when you are checking the notes again. Okay, so these are all U1, these are all U2. Similarly on the rows as well. Okay, now that we have KFC, all that's left is the what was this again? Oh, D. So we have the KFD left. So let's just do the KFD right over here. So KFD equals that. There we go. The 270 plus 45. 270 plus 45 degrees is 315 degrees. So at 315 degrees, cos theta is equals to 0.707, and sine 315 degrees turns out to be negative 0.707. Okay, so if you run those values here, we're gonna get 0.5, 0.5 here, so C squared is 0.5, then C and S is going to be a negative 0.5, there you go, a negative 0.5. Okay, and right after that, we're gonna have another negative 0.5 here and a 0.5 here. Okay, so that is done as well for KFD. So we have all the U1 and U2 values. So what's there's left to do is to add them and get our main K for the entire truss. So main K for the entire truss, there is going to also be the SX value. So we did not say what the SX value was. SX meaning EA by L. So let's just consider the EA by L to be 1000. Okay, so we have SX right over here, and let's just not think too much about the units here. Let's just solve the thing. Okay, Alright, so we have Sx, and then we're gonna have to do the plus of the all u1. So this is u1, u1 is 1, u1 is 0.5, so 1 plus 0.5, then again we have 0 and we have 0.5. So 1 plus 0.5 plus 0.5 is going to be 2. There you go. And now u2, u1 position. So this is u2, this is u1, this is 0. Okay, this is 0.5, so 0.5 plus 0 and then minus 0.5. So plus 0.5 and minus 0.5 turns out to be 0. So we have 0. Then the u1, u2 position, u1, u2 position, it is 0. Then we have 0.5, then 0, and then minus 0.5. So plus 0.5 and minus 0.5 is 0. And at the end we have u2, u2 position. So 2 by 2 is 2 and 2 is 0. Again 2 and 2 is 0.5 plus 1 plus 0.5. So 2 0.5s and 1 positive 1. So that's going to end up with 2. So this is the stiffness matrix for the entire truss. We have the stiffness matrix for the entire truss. Now, if we just formulate the whole thing, we know the value of Sx to be 1000. So if we formulate the whole thing, we're going to end up with something like this. And we also know that at F, the position F, there is a horizontal force, which is of 10 kgs. Alright, so if we do the final equation, that is going to be something like this: 1000, 2, 0, 0, 2. Along with that, we have u1, u2 equals to the force vectors. The force vectors are the top of the line is for the horizontal forces, as you know, so that's going to be 10. There you go. At the F location, that is 10. You know, both u1 and u2 are located at the F, so we're calculating for the F joint right over here. That is why we can consider the forces at the F joint right over there. So we're going to take the horizontal force 10, and there are no vertical forces here at the F joint, so we're going to just consider that force to be 0. Okay, so now that we have everything here, what we can do is we can just solve for this. And if we solve for this, we're going to get the displacement u1 and u2. So the only displacements that are available in this truss, we're going to get that. But if we were to know the support reactions, then we cannot do this shortcut. We have to write out the matrix for all of the displacements and do the procedures that we had done in the very first example that we have done. Right, that is what we need to do. But we can always cut out the zero force members to get a lesser work scheme. Okay, so this is what you can do by hand fairly easily. If you were to just calculate the displacements like this, you can do it by hand without the help of any software or computer programs like that. Okay, so that's it for this video, and I hope this video was helpful for you and you got to learn something new. And another thing is, if some of you are wondering that, hey, at first you said that you should always consider the lowest degrees, the lowest angles, but this time you just went on from from F to other points, and that is the longest degrees, the longest bearing angles. So the reason for me doing that is, if I had considered the lower bearing angle, for example, if I had considered GF and then BF and then CF, in that case the F, the 1, 2 would have become the later part, this later part of the equation. That way we could not have developed such a simple equation to get the displacements, right? We would have to write the whole thing, the whole equation for all the members. We did not write the whole equation for all the members because we already knew that out of 4 displacements, 2 displacements are null because there's only one joint that does not have any support to it. Okay, so that is why we took the larger bearing angle path this time, just to make our work shorter. But if we were to do the support reaction calculations and also the member force determining then in that case we could have gone for the smaller bearing angles. Well, we can do it like this as well by developing the whole equations, but in that case you can also go for the smaller bearing angles if you like. Okay, alright, so yeah, I hope this was helpful for you and you got to learn something new. Thank you very much for watching.